NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will prove a powerful relation for a quadratic equation. Here is the theorem statement. We assume a not equal to 0. 4ax squared plus bx plus c equals 0. If x2 equals k times x1, then b squared over ac equals the square of k plus 1 divided by k. We will use Vieta's formulas. Let x1 and x2 be the roots. Then, the sum x1 plus x2 equals negative b over a, and the product x1 times x2 equals c over a. Because x2 equals k times x1, substitute into the sum. We get x1 plus k x1 equals negative b over a. Factor x1 to obtain x1 times the quantity 1 plus k equals negative b over a. Therefore, x1 equals negative b divided by a times the quantity k plus 1. Next, x2 equals k times x1, which becomes negative bk over a times the quantity k plus 1. Now use the product relation x1 times x2 equals c over a and plug the two expressions in. Multiply both sides by a to get b squared k over a times the quantity k plus 1 squared equals c. Then multiply both sides by a and by k. And finally divide by ac to isolate b squared over ac. This yields b squared over ac equals the quantity k plus 1 squared over k. Intuitively, the constraint that one root is a constant multiple of the other, combined with Vieta's sum and product, pins down a fixed ratio between the coefficients. And that ratio is exactly b squared over ac equals the square of k plus 1 over k. Proof complete. In this lesson, we will solve for m in a quadratic where the roots have a given ratio. Here is the example we will follow exactly step by step. Step 1. Use the rule for a quadratic when one root is k times the other. If x2 equals k times x1, then b squared over ac equals parenthesis k plus 1 close parenthesis squared over k. For our problem, k equals 4. Step 2. Identify the coefficients a, b, and c from the quadratic. Then substitute them into the fraction on the left side. Step 3. Cross-multiply and simplify, following the exact algebraic steps. Then divide by 2. Step 4. Expand the square and rearrange to standard quadratic form. Step 5. Compute the discriminant delta equals b squared minus 4ac. Now plug in a equals 2, b equals negative 21. Delta equals b squared minus 4ac. Now plug in a equals 2, b equals negative 21. c equals 52. Simplify to get 25, which is positive. Step 6. Use the quadratic formula. M equals negative b plus or minus the square root of delta, all over 2a. Substitute values and simplify carefully. Step 7. Compute both values. Final answer. M equals 13 over 2, or M equals 4. Step 7. Compute both values. Final answer. M equals 13 over 2, or M equals 4. In this lesson, we will solve for the parameter m so that one root of the quadratic is 5 times the other. We will follow a clean algebraic recipe that works for any ratio of roots. Step 1. Encode the ratio using a single parameter k. We are told x sub 1 equals 5 times x sub 2, so we set k equals 5. Step 2. Use the ratio identity for quadratics. If ax squared plus bx plus c equals 0 has roots in the ratio k to 1, then b squared over ac equals the quantity k plus 1 squared divided by k. Let's write that identity. Step 3. Substitute a equals 1, b equals negative 12, c equals 3m plus 2, and k equals 5. Step 4. Simplify each side and solve the proportion. We get 144 over 3m plus 2 equals 36 over 5. Cross-multiply to isolate m. Step 5. Divide both sides by 36, and then solve the linear equation for m. We obtain m equals 6. Quick check. Substitute m equals 6 back into the quadratic. We get x squared minus 12x plus 20 equals 0. The roots are 10 and 2, which have a ratio of 5 to 1. Verified. In this lesson, we will solve a quadratic parameter problem step by step. The equation is x squared minus 3 x minus 1 equals 0. One root is 4 times the negative of the other root. We will solve for m with two clean methods. Method 1. Use a ratio of roots identity. Start by encoding the relation. Let x1 and x2 be the roots. We are told x1 equals 4 times negative x2, so x1 equals negative 4x2. That means the ratio k equals negative 4. Next, we will use the identity b squared divided by ac equals k plus 1 squared over k. For our quadratic, a equals 1, b equals negative 3m, and c equals negative 1. Substitute and simplify carefully. Compute each side. On the left, 9m squared over negative 1. On the right, negative 3 squared over negative 4 equals 9 over negative 4. Now equate and solve for m. Divide both sides by negative 36 to get m squared equals 1/4. Therefore, m equals plus or minus 1/2. Method 2. Use Vieta relationships. From x1 equals negative 4x2, and the product of roots equals c over equals negative 1, we substitute to get negative 4x2 squared equals negative 1. So x2 squared equals 1/4, which gives x2 equals plus or minus 1/2. Now plug each root into the original quadratic to solve for m. First, take x equals positive 1/2. Substituting yields 1/4 minus 3m over 2 minus 1 equals 0. Multiply by 4 to clear denominators, giving 1 minus 6m minus 4 equals 0. Therefore, negative 6m equals 3, and m equals negative 1/2. Next, take x equals negative 1/2. The signs flip on the middle term. We get 1/4 plus 3m over 2 minus 1 equals 0. Multiply by 4. We obtain 1 plus 6m minus 4 equals 0. So 6m equals 3 and m equals positive 1/2. Both methods agree. The parameter m can be either plus 1/2 or minus 1/2. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.